Welcome back. In today's video, a circuit is constructed in the topology of a inverting amplifier, and that is the topology we have here. We ground the V plus input of the amplifier, and we send the input source or the input signal through R1. So instead of, so that we're talking about the V plus terminal, instead of grounding that terminal, the V plus input is produced, is also connected to the V in source. So thus we need to connect V plus to the V in source and then find an expression for the resulting output voltage by superimposing the responses produced by non-inverting and inverting amplifier gains. So the first thing we need to do is modify the topology for that. Plus or minus, this is still V in, because instead of connected to ground, it's connected to the V in source. So to make this a little bit simpler, or not simpler, but to not get confused, I should probably just call V1 and call this V2, and then go ahead. Well, let's just leave it at V in. It makes more sense. We know that both are equal. So then we can start from a non-inverting topology. And by doing that, we can start from the midpoint of the voltage division. Well, if we start from the midpoint of the voltage division V minus, that will be inverting. So for the non-inverting, we know that we ground the end of R1. So in this case, for non-inverting, we ground R1 and apply the input to the V plus terminal, and that would give a non-inverting configuration. So for the non-inverting, we're going to start with 1, and that would be V minus is equal, by voltage division, R1 divided by R1 plus R2 times V out. And we then say by virtual short, V minus, and this is for the non-inverting case, V minus is equal to V plus, which is equal to V in. So V minus then change to V in. Then finding V out, we can thus say V out is equal to R1 plus R2 divided by R1 times V in. So that is the output voltage for the non-inverting case. For the inverting case, this is where we use V minus at the midpoint of the voltage division between V in and V out. So for this case, we ground the V positive terminal, and always by virtual short, we can assign the voltage at V positive to the voltage at V minus, vice versa. So then we can say 2 for the inverting amplifier. We can then say that the voltage at V plus can be assigned to the voltage at V minus. In this case, V plus is held at ground, so that's 0 volts. We start from the midpoint, so that V minus we know is going to be 0. But if we ground, and in this case, let's just, for simplicity, this is held at ground at the moment for the inverting case. So then we can then use a voltage division, or we can use superposition, and we can ground V out. We can ground V in. Let's ground V in first. So if we ground V in, we can then say the voltage across R1 by voltage division is R1 divided by R1 plus R2 times V in. And in this case, that's incorrect, because if we ground V in, that's time V out. Then we can go ahead and say, In this case, we ground V out, so we then find the voltage across R2 with reference to ground. So that's R2 divided by R2 plus R1 times V in. We then can solve for V out by setting V minus to 0 by virtual short. Move over V out, and that is equal to negative, we know both cancel out, and that is R2 divided by R1 times V in. So there we have the response, the output response, V out, the response to the input signal for a non-inverting and an inverting topology. We can then go ahead and superimpose both of them. So thus we would have, if we know V in is equal, V in, both V in is equal, so then we can say the output, so V out is equal to the output from the non-inverting. So that's R1 plus R2 divided by R1 times V in. Superimpose mean add, so we add that to the output from the inverting, and that's R2 divided by R1 times V in. And superimposing both, which we're doing, we know V in are both equal, so thus we can factor out V in. R1 divided by R1 is 1. R2 divided by R1 minus R2 divided by R1. Basically, we see that V out is equal to V in. So in this case, what we see is that if we tie in a inverting amplifier configuration, if we tie V plus to V in, then we get a voltage follower. So V out is equal to V in. And in this case, that's it. That is the output. So that is the expression. Find an expression for the resulting output voltage by superimposing the response produced by a non-inverting and an inverting amplifier gain. So that's it for this problem. See you in the next one. Bye.